Hi everyone, this is Jared Anderson. This is my Math 626 problem assignment video. My topic for this will be zeros of quadratics. The course that I've chosen for the problem solving activity is Algebra 1B. At my school, Algebra 1B comes after Algebra 1A. 1A focuses more on the 8th grade standards and just kind of honing those skills, making sure students are ready for high school. Algebra 1B is kind of our typical or traditional 9th grade standards for mathematics. Why I chose this course is mainly just because I teach it a lot. This is my second year teaching here in Wilmer, and we teach on a block schedule. Typically, people might teach up to 3 different blocks or different classes at a time. And we kind of rotate through on a term basis then. So last year I taught Algebra 1B 4 times in total, or should I say to 4 different groups of students. This year I've taught it twice, and most likely I'm going to teach it again and again. So I wanted to pick a topic from this course, Algebra 1B, that I could use in the future. Again, the topic that I've chosen for this problem-solving activity is the zeros of quadratic functions. When I say zeros, that could also be understood as intercepts. The standard that I'll be focusing on is identifying the vertex, line of symmetry, and intercepts of the parabola corresponding to a quadratic function. I also really like here in the standard that it mentions you can use graphical methods or symbolic methods because I do want students to be able to do both. Reason I chose this topic is because I know that my students typically struggle with some things from quadratics, especially this idea of solving for zeros and recognizing that there are multiple ways to do it. Again, you can graph, you can use different symbolic ways, you can factor, multiple different ways to solve for it. The activity that we'll work on today then will hopefully, I'm going to use 2 words here, both encourage and force students to try solving with a different method. I want them to be able to recognize multiple ways to do it. Because this is a problem-solving activity, we will kind of discuss the 4-stage model. Again, students can kind of be reminded that these are the 4 stages that they should be looking for. They will actually have to do a write-up on each one. So it would be probably helpful just to kind of reiterate what each one is. Obviously, stage number 1 is just reading and understanding what the problem is saying, what it's looking for in a solution. Stage number 2 is devising a plan, kind of creating a plan or a strategy, identifying what you're going to use to actually do the problem and solve it out. Stage 3 is actually going through then and doing that plan, going through the work of actually figuring out what everything is that you need to do and then doing it. And then level 4 is looking back and examining all of your work and your solution to make sure everything makes sense. Now, in our problem-solving activity, we're really going to be mainly looking at just one problem, but there are 3 different versions of it. So we're going to look at all 3 versions. I'm not going to go into a lot of detail on any of them except for the first one, version number 1. Version number 1 goes as follows. Bradley and Samantha go to different schools, but they are each launching model rockets off at their school for Yuri's night. Bradley's school wants him to launch it from the ground and use an engine that launches the rocket at 152 feet per second. The height in feet of Bradley's rocket after t seconds can be modeled by the function h of t equals negative 16t squared plus 152t. Samantha's school wants her to launch her rocket from the roof of a building 144 feet above the ground with an engine that launches the rocket at 128 feet per second. The height in feet of Samantha's rocket after t seconds can be modeled by the function h of t equals negative 16t squared plus 128t plus 144. So the main question at the end of all of this setup is whose rocket will land first? So again, we want to think about what that sentence is actually asking, kind of the perspective of whose rocket lands first. What does that mean for time? Another version of the problem will pretty much just change the names. Instead of using over here Bradley and Samantha, we change it to Suleika and Jose. We change some of the values. Instead of where Bradley was launching from the ground and his rocket was 152 feet per second, Suleika is also launching from the ground but at 136 feet per second. So her function will change a little bit. Same thing, instead of what Sam had, Jose's rocket will be launched from a different building height with a different initial velocity. So again, his function will change only slightly. Now the big difference here is the wording of the actual problem. So in problem number 1, we were asked whose rocket will land first. So again, students will have to think what that means for their question, what they're actually trying to answer. In problem number 2, it says whose rocket will stay in the air longer. So they're looking for a very similar thing. It's just slightly different. And students will kind of need to be able to discover or see that difference as they're working on the problems here. Lastly, problem number 3, again, the actual question in the end is whose rocket will land first. So that was one thing that they kind of need to identify there. But also, in this case, different people, different names of our students, and both people in this case are launching from a roof. So the roof and the initial velocity will be different for each of the equations given. Otherwise, these three are basically almost the same kind of a problem, same kind of a setup. However, in our activity, we will first be focusing on problems 1 and 2. And this is how it's going to look. Students will work in pairs. Each student then will either get problem 1 or 2 to begin with. So down here you can kind of see I have student A has problem 1 and student B has problem 2. Each student will begin the 4-stage model by reading their own problem and writing down what they understand about it. This includes just writing down what is being asked, what a solution would look like, and examples of answers that don't make sense and why. Once they have all of that in their head, they need to write it down on their paper. So again, student A has paper number 1, student B has paper number 2, corresponding with those problems. After students will understand their own problem and write down their understandings, they switch papers with their partner. They'll read their partner's problem and how their partner understood it. So we're going to switch. Number 1 goes over here, and number 2 goes over here. So each student has a different paper and a different problem. Now remember, the two problems are pretty similar to each other. But again, they're reading it through, kind of seeing how they're similar, how they're different, and what their partner understood about it. Now, students will devise a plan to solve the problem that their partner started with. Students must write down the plan of how they think this problem should be solved. So even though student B started with number 2, A is going to write down the plan, devise up the plan of what they think they should do to solve that one. Similarly, B is going to write down the plan to solve problem number 1. After students devise the plan and write it down, they will switch again with their partner and read their partner's plan for solving the problem they started with. So again, we'll switch these back. B gets 2 and A gets 1. They're reading up the plan that their partner wrote down to carry out through this problem. Students will now carry out the plan that their partner designed to solve the problem. Students will write down their work of how they solved the problem and write down their solution. So again, A is now back with problem number 1, the one that he started with, but B wrote down how he should solve it. Same thing with student B and problem number 2. After students have carried out that plan then, they will switch with their partner again and read their partner's solution. So student B finally solved his problem number 2. He's going to give that problem back to A, and A will give problem number 1 back to B. What the students are doing now is just double checking their partner's work and their solution to make sure the work is accurate and that the solution actually makes sense. Students will write down whether or not they agree with their partner's solution after checking it over and why or why not they actually agree. Students will then switch with their partner again to see what they read. So actually I think at this point A has 2 and B has 1. They're going to switch one more time. So go over here and over here so that they can see what their partner said about their solution. Okay? After discussing with their partners what they said, they can toss these papers. They no longer need 1 and 3. They're going to start working on problem number 3 together. They'll be asked to turn in a write-up for the 4-stage model for this problem. Okay, so after all, mostly it'll be a very similar problem, but they should be looking and seeing new ways to go about solving this problem together. I like using the four-stage model for this because, again, it helps students kind of look over and articulate what the problem is, how they need to solve it. Again, using a partner, when you devise a plan, you really have to be good at articulating exactly what you're trying to do with it. Carrying out the plan then, you're carrying out a plan that somebody else devised, so it makes sure that you are good at not only understanding what they're saying, but understand the math behind it. And then lastly, of course, checking over the solution. Well, somebody else made the solution, so it makes sense that you would have to check it just to make sure everything was correct then. Lastly, though, when you get to work on it together, when we go back and do problem number 3 together, you do all of this process as one. So it's not this switch back and forth. You do get to kind of go through the whole process all as one, that you got to be a part of each one. So that would be my activity for the problem solving uh, assignment. Thank you much.